Here is help in writing the geometric sequence in summation notation, then finding the sum. Since it's geometric, we know we're using a sub n equals a sub 1 r to the n minus 1, and that'll help us in writing our equation for summation notation. We know that the first term is 8 over 3, and then r we can find by finding the ratio between a sub 2 over a sub 1, so 2 over 8 thirds. So this becomes 2 divided by 8 thirds, or 2 times 3 over 8, which reduces to 3 over 4. So we can write our general equation as a sub n, a sub 1 is 8 thirds, times 3 over 4 raised to the n minus 1. So we want to write it in summation notation. So n equals 1, and we write our equation 8 thirds, 3 fourths to the n minus 1. And what we need to find is the number on top, right? So here's our lower limit where we start, and this is where we stop. We do know a sub n, we just don't know what the n value is. Where does it stop? So a sub n is 243 over 512. So I'm going to take 243 over 512 and set it equal to the equation and see if I can find n. So 243 over 512 equals 8 thirds over 3 fourths times raised to the n minus 1. So first what I want to do is isolate the exponential on the right. So I'm going to multiply by the reciprocal 3/8 to both sides. So that cancels it out. Now really what I know is that because 243 over 512 is part of this geometric sequence, then I know that the numbers are going to come from here. Meaning that I'm going to have 243 and 512, and I should be able to make the same base with what I have on this left side. So what I want to do is go ahead and break it down instead of multiply. I want to get down to where I have 3 fourths raised to some power on the left. So I'm going to break down 243 and 512. So 3 times 243, I can divide 9 into it. So then that becomes 243 is 9 times 27. And then over, I have 8 times 512. So 512, I'm going to divide 16 into it. So I get 512 is 16 times 32. And then that'll equals a 3 fourths to the n minus 1. Again, what I'm trying to do is I want to get 3 over 4 on this left side and then just get it raised to some power. So I'm going to keep on continuing to break it down. So I can rewrite 9 is really 3 squared, and 27 is 3 to the third. And then 16 I can write as 4 squared. 32, that's a little tricky, but that's 16 times 2. And then 8, I can say that's 4 times 2, right? I'm trying to make 4s, and so I see there are going to be 4s in here. Now, the numerator, I have 3 to the first, 3 squared, and 3 to the third. So if I add that all together, the numerator is 3 to the 6th power over, and let's see, I can make these two become a 4. This 16 breaks down to 4 times 4, so 4 times 4. Then I have this 4, and then a 4 squared, which is right here. So 1, 2, 3, 4, 5, 6. So I have 4 to the 6th in the denominator. And that equals a 3 fourths to the n minus 1. So I'm going to rewrite the left as 3 over 4 raised to the 6th power equals 3 fourths to the n minus 1. Now the bases are the same, so that means the exponents can equal each other. So 6 equals n minus 1, or n equals 7. So that's the number that we can put all the way at the top. And so we're going to put n is 7 right here, and that is our geometric sequence in summation notation. Now the next thing is we need to find the sum of the 7 terms. So sum of 7 equals, and the formula we're using is S sub n is a sub 1 times 1 minus r to the n over 1 minus r. Okay, so it's a geometric series that is finite. It ends at 7. So a sub 1 is 8/3 times 1 minus r, which is 3/4 raised to the n, which is 7, all over 1 minus 3/4. Okay, so we have 8/3, and then 1 minus, I'm going to take 3 to the 7th and 4 to the 7th. 3 to the 7th is 2187. 4 to the 7th is 16,384. And then in the denominator, if take 1 minus 3/4, the denominator would be just 1/4. Okay, so we want to continue to work with this. So what I'm going to do is multiply by 4 in order to cancel this denominator out. And so when I multiply by 4, then I'm going to multiply the 4 to the 8 here, right? So really I'm just taking it and flipping it over. So I'm just going to change that to 4 times 8. So we have 32 over 3. Then we need a common denominator in order to subtract and in the numerator. And so you know we need 16,384 over 16,384 in order to combine these terms. So I can take 16,384 minus 2187. So that leaves us with 14197 all over the 16,384. And then we could reduce. So 3 doesn't go into 14,197. It does not go into there. But I'm going to see if 32 goes into 16,384. And it does. It goes in 512 times. So to simplify it a little bit, we have 14197, and then we have 512 times 3, which would be 1,536. And so that is the sum of the first 7 terms.